available. So for those who did see kind of like the posts, so apologies, it was a little bit late in Discord and also on the kind of Cumulocity chat. Today for our demo, we kind of wanted to preview some, like an in-development feature, which we're calling Tedge Flows, which is all about trying to make it, if you need to add some custom logic to do some translation of some MQT messages, or maybe do some rudimentary analytics on some kind of signals, that you can actually do this without writing your own application. So you can today write your own application to do whatever you want, and all of the MQT APIs are public. So that's what we encouraged users to do in the past. But we basically found that maybe for a lot of people, that was actually quite a high bar to then write your own application, because you then had to worry about the MQT client and how you handle the reconnects, and even using some of the MQT libraries like the Python PayU library was always a bit of a pain to use, and it was very easy to use it wrong, which then meant at some point your application stopped communicating. So the idea with Tedge Flows is that it is a JavaScript-based engine, which we run a function for you, or one or two functions, which have particular mechanics, which Tito will go in shortly. And all of it's encapsulated and nice sandboxed. So it's just really translation of messages, or like doing thresholding or whatever, to then do your application. And it's just that standalone thing, which is also then generic across any CPU architecture, because in the end, we're running the engine, the JavaScript engine, and then we're just executing your things, and you don't need to worry about anything else. So if you get disconnected from MQT, we'll handle the reconnect and do all those things. So we're hoping that this will be a very prominent part of ThinEdge to also extend to your custom logic, and then integrate it with all of the parts within ThinEdge. So this might not mean anything at the moment, but hopefully at the end of the meeting, you'll have a bit more of an idea. So the idea is we wanted to start getting a bit of like being a bit more public, because we have started this a while ago, because it is a big topic. But we're starting to kind of communicate a little bit more, and we've done a few teasers, maybe informally to a few different customers or a few internal people, but we kind of wanted to start opening it up a little bit, even though it's not in a full ready state. So that means all of the API is subject to change. So I probably wouldn't encourage people to use this in any kind of projects just yet, but we want to start people to get, aware of it, and also maybe use the bleeding edge, but expect things to change. So on that note, I'll hand over to Didier. We'll see if we can answer the question, because I'm imagining there's going to be a lot of questions. We'll see that, because it's such a big topic, that put up your hand, and then we'll see if we can pause when it's appropriate to then answer them, hopefully in the context. And then at the end, if you just have like general questions, then I'll ask them to get held to the end, or ask them in the chat, and then we'll see if we can respond. Cool. Okay, that's enough for me. So over to you, Didier. Thanks.
So for the point of Tedge Flows is to provide your own mapping rules. So first, we need to understand what is a mapper. A mapper is just some service that is running behind the scene. We have some for Cumulocity, another for Azure or AWS. And this service is running behind the scene to consume messages from some source, and to transform the messages on the fly, and to send them to another target. It can be consuming messages from sensors, sending data to Cumulocity, and vice versa, consuming, say, operations from Cumulocity, and dispatching these messages after some transformation to the appropriate target. And so this is mostly consuming messages and from different sources, and pushing them to different targets, and on the fly applying some transformation, formatting, because we have different formats. Cumulocity JSON is not the same as single JSON. We need some time to filter out the messages, because we don't want to send everything to the cloud. Sometimes we want to group messages, because it's better to group, say, 10 measurements and to send a single message to the cloud. And also some very sophisticated case, maybe you want to adapt the messages, say to change a measurement unit. You receive some data using Fahrenheit and you want to send Celsius data. So you want to adapt this. Today we have some mappers, but everything is built in. If you want to change something, you have to ask something to post a request to a Synergy team. Please, can you add some way to put measurements? Tomorrow, using Tedge Flows, you will be able to do this alone. With Tedge Flow, you can define your own message transformation, say consuming some sensor measurements provided using CSV, and you can transform this along JSON. And so Synergy can understand that. So message transformation, but also you will have a full control of the flows from source to the target. I would like to consume messages from this MQTT topic and this and send that to this cloud, or I can consume this from not an MQTT topic, but say from a command that I will run every hours or every minute, and I will consume the messages produced by this command and transform them, push them elsewhere to the cloud or to another MQTT topic. So the plan is really to open all the transformation and all the flows from source to target. Currently, what we have today is something that is fully apart. We have a Tedge Flows mapper that use only custom transformations. But the plan for tomorrow is to have something that will be fully integrated with the other mappers. Say the ability on the Cumulocity mapper to add your own transformation, your own preparation, and the ability to triage messages, to say, oh, these messages I will send to Cumulocity, but I prefer to send them to another, say, to the new Cumulocity MQTT service. So this ability will be added following this. So for the demo, yeah.
Yep, your console looks good.
Yeah, it's not nice because my plan was to have many windows.
Yeah, that does make it a bit annoying for sure.
Yeah, I would try switching from one screen to another. The plan, I will start with something simple, just to transform messages received from Cumulocity. So we have a Cumulocity mapper. On purpose, it's been disabled right now. And so no messages are currently transformed using the mapper. So I have messages sent by Cumulocity along CSV. So I have a topic that is provided by Cumulocity to say, oh, I have some memory percentage used, and I have a timestamp and the value. And I would like to transform this into some JSON that will be understood by Synergy. So for that, maybe, yeah, so I have to find a flow. Right, so not something. So for that, I will write a JavaScript function that consume messages. So a single message, I can make all the transformation on that message, and the result is just 1, 0, or many messages. In that case, I will just have one message in, one message out. So I just have a regular CSV. So in the message, it's given the topic. It was some collected topic and a payload. Both are using some CSV, not really CSV because one is separated by slash, the other by columns. But anyway, I can pass the data. I can throw errors, which will be handled by the framework. I can extract the data. In that case, I can discover what is type of measurement. Oh, this is about the CPU. This is the percentage. I can the first number is a time, and I have a value. So I can just from that produce a message. I have to provide a topic. So the default will be to send this to collect the some signage, collect the measurement, and I produce some JSON here, a payload that is so the times group and the measurements value. When I have this, it's not enough. So I will copy this file to, or maybe I have to run the Tedge Flow first. I will use this later just to avoid too many swaps from you. So I will copy this code ID to Tedge Flow. This is a place where I will put all the scripts, all the definition, flow definitions. Right now, it will be not enough. Because I just have a script. I need to say, oh, things are coming from such or such sources, and I want to send this. So this is done using a flow definition. And this one is very basic. I just have an input. I would like to collect everything coming from this topic. So collect the measurements. And I will apply a single transformation that is to that was defined by this JavaScript transformation. And if I push this to yeah, it's not funny. If I change from one script to other, yes, it's okay. Yeah, that's good. So I will run the flows. So this is a mapper. This mapper is just running all the flows. Currently, there is none. And I will add the first one. So I will push these flows. The flow quality tunnel is correct place. This is loaded by this by the mapper, and we start to have a transformation. So we are still the source, and now in this here I'm listing. So just to be sure this is that. Yeah, so I'm collecting all the transform messages. This one are produced by the JavaScript. Just to be sure this is currently done by that, I will just add introduce some bugs there just to see. I will edit in place the Tedge Flows. I will put this as timestamp. Just write this. This is really reloaded by the flows. Now I have something where I have no more time, but time zone. This is dynamic and defined by the users. So this is very basic step. I just have a single transformation, and all the messages are going through. I have a one-to-one relationship between input and output. If you notice, I have here correctly just sending a message, a measurement per line, per message. It will be better for you on the Cumulocity side to have a bunch of messages to group all the measurements coming from the same sequence into a single message. So to do that, I will introduce another script. So this script flows is that one. So in that case, we still have this all message function that will be executed for each and every message. But I will have another function that will be called on different intervals. In that case, I will try to call this every, say, every 10 seconds. And the purpose of these two functions is to work in pair. The first one will consume the messages, cache the messages in some static data, and every 10 seconds, this method will be called by Tedge Flows. And there you have the ability to process a batch. Here we will consume everything in the batch, so the new batch will be empty after this method call. But anyway, I will extract all the measurements, and I will build a huge message where all the messages are collected, grouped. Here, somehow I'm using this is a kind of JavaScript trick to merge messages. I have measurements related to CPU, I have measurements related to memory usage, and I will merge all of them in a single message. But somehow this is about JavaScript. The key point about Tedge Flows is this is the relationship between these two on message and on interval functions work in pair. So again, I will move this script to Tedge Flows. Nothing changed because this is used as not used. So I have to edit my flow to say, oh no. So if I edit this flow for example, I have to say, oh no, I have a second step. It's not enough to transform everything from quality to smooth JSON. I have to group the messages. And yeah, so here I have to provide this the name of the script. Yeah. Just want to be sure this is the correct name. Group measurements. And I will call this at some interval. So I will take every 2 seconds. I would like to have a new group. So I just update my flow. This should have been loaded. There was some error before, but now it's working. And if I look at the messages now, so now the measurements are grouped. I have not a single measurement. If you notice different now, I have this time. But I have also not only CPU, but I also have everything related to memory. It has been grouped during 3 seconds, which we got many messages. So this is a new feature. I can just extend a working flow is another step to group messages.
And maybe that's a good time to just kind of reflect on some of those points. So you're flexible to deploy it how you want. So if you have one mega flow, which is meant to do all of your JavaScript in one thing, and you're doing like bundling from all the dependencies, that's also fine. So you can put everything into a single step, fine. Or you can also like put it into multiple steps, and you can think of it like a chain. So it's just input goes into the first one, and that output goes into the second input, and they're just daisy chained more or less through. But by being able to have these two kind of flexible ways to kind of approach the problem, is that you can also solve a lot of more difficult problems when it comes to what happens in step one if you're not the owner of that JavaScript. Like, you don't really want to be modifying someone's existing code, and how do we kind of like add functionality to it without kind of modifying that JavaScript ourselves. But again, it's kind of up to you how you want to use it. But it's a really powerful mechanism that can be very flexible for a very large range of use cases.
That's a good point, because I failed to explain how the messages are flowing. So we consume all the messages from the source, and for each message goes through all the steps. Here, so the first step is to transform the collected message into a single message. And this script can produce 0, 1, or more messages. All of them will be pushed to the next step. And again, the next step can produce 0, 1, or more messages. So you have, starting from one message, you have more and more messages, or sometimes nothing, because one can decide to filter out a message. And all the messages will go through up to the end. There is no specific output there. The default is MQTT, but we also provide other sources. You can push messages to disk. Another point that is also important about this flow, this is when, if I look this, here I have two functions, and both have the ability to return messages. So this one consumes everything and return nothing. So when a message arrives, the messages are simply batched. But for some reason, you can say, oh, I cannot batch this message. I will return the message. So both, and this message will be processed. And same on interval. You can send back all the messages, but I can make a choice. I can implement some sliding window, for instance. Yeah, it's a fixed window, but I can imagine some sliding window where I output only some of the messages. So this is really a flow of message, and each and every function on interval on message can decide to keep the message, filter out the message, split the message, whatever. So this ability to send 0, 1, or more messages. So this was basic examples. I have a more involved one. Just have to find this one. So yes, so this is something to consume messages, read from journal D. And I would like to create alarms if there are too many errors from the different services running on the device. So this script is implemented in using TypeScript. So So this is also the nice part of JavaScript, that you have different flavors of the language, and you are not stuck to a very low-level language. But we have the same. I think we have a message function. We have this ability to consume all the different messages, assuming these messages are coming from journal D. So we expect journal D messages. I will show you later how to have them. And same idea, I will be able to store the different messages in a local state from the module, and on different interval, I will be able to see what has been received. Oh, I have too many rows, so I have to, so roughly I have too many rows somewhere. I have to trigger an alarm. So this is done using regular signage messages. So this is a signage message, and this is an alarm, and here's text, payload of this alarm. So this is a bit more involved functions, but makes sense. So this was TypeScript. On my side, I will not use TypeScript because the engine is not aware of TypeScript. We will just be able to process JavaScript, but it can be something that has been transpiled. So this JavaScript module has been transpiled from as a TypeScript module definition. So the transpilation not only move everything from TypeScript to JavaScript, but also gather all the definition units. So what is journal D message? There was different files, TypeScript file. Here you just have a single one. Everything is in one file, but I still have my own message function. So I have the same code here, and so I can push that to a flow. So I will do this. We'll just push this one to flows first. So now I just have a new JavaScript. Nothing changed from the flow perspective here. The next step is to define the flow itself. How can I consume the messages, and what will be the steps, processing steps? So this is done using a TOML file. So this seems to be very different because TOML has very different flavors, syntax flavors. So here we just have the same thing, the definition of the input. This time is not an MQTT, but this is a command. And we have different steps. So we just have a single step. This is a way to say that I have a list of steps, and this is one step. Again, the step is a bit more involved. I still have my script. This is the script. I still have this interval to say, oh, every 30 seconds, I would like to trigger the gathering of all the messages. And I have some config. Yeah, I will tell you a word about configure. So we can configure a script from the TOML, and all this data, this config value, are pushed to the script. So the script can, for instance, have different functions. Here I have a topic, and here I can provide a value. But in the script, I will be able to use that topic or to provide some default if nothing is provided here. Anyway, I have this script, and the key point I would like to show you is a command. This is how I will consume the messages. So in that case, I will use journal.ctl as a command. So every 15 seconds, I will run this command, and I use a smart feature for journal.ctl to have some watermark. So journal.ctl will consume a given number of messages and persist in this file where what is the latest messages that has been retrieved from the functionality and sent to Tedge Flows. So every 15 seconds, I will read a new bunch of messages that will consume them using this script, the script here. Also, notice that I'm consuming a journal output using JSON, so I can process them in second line in my script. So now I just have to push that to the flows. So this time I load a new flow, and I will be able to see messages from, I think the simpler is to, I will stop to listen to that, and to listen to I will listen all messages coming on the T topics. So I have many of them because oh yeah, I will stop. Yeah, just to remove noise. I will remove the flow related to quality. Remove this flow. Again, this is dynamic. This flow has been removed. And I have less noise right now. So I just have, and by the way, I noticed the first message sent by my log search flow. So I have some statistics, because this has been configured to have statistics to share how many messages have been received during this period of time. And I have a message, an alarm, with an empty payload, meaning in fact it's erase the alarm. So there is no alarm for coming from log search. Again, every 15 seconds I will have such output. I can simulate, so I have a trick to produce errors. So this is just because yeah, this trigger errors in the Tedge agent. So now I will observe. So this is the message I just sent. And yes, I have a new alarm telling that some too many messages has been detected during this period of time. Okay, it's what I would like to demo. Any questions?
Or maybe just from the logs search. So I mean, that's kind of like the classic example that you kind of want to monitor your machine. Is my machine doing what it should be doing? Because I can monitor all the services which are running. And so, you know, being able to interface with different information sources is critical. And especially at the edge, they're going to be very, very different. So there's being at least able to run a command or read a file as the input, not in the JavaScript function, then at least enables you to expose or get more information. Because at the end, if you can kind of execute a process, you can kind of make it secure. So if it's all under your pseudo as rules, so if the Tedge user isn't able to execute something, then you still have protection there. So it's not blindly executing everything as root, absolutely not. But you can also, create your simple wrapper scripts, which then do some kind of conversion and then pass it to the flow if you can't do something in JavaScript. So there's a lot of opportunities there that ways to customize the setup. But then with the monitoring your system, it's just about, you only really want to be alerted when something's wrong. Like, don't send the statistics to the cloud. Like, no one is interested in those statistics, like in daily operations. So you can then do your alarming on top of that. And all of that is very, very simple. So that was probably a more complex example because it's, it's just trying to push the boundaries, what can you actually do in it? So we have all those code available online to look at the moment if you just want to go, what does that look like? But it shows it's quite powerful and can be used beyond kind of just simple mapping rules. And I think we touched a little bit on the transpilation topic. In the end, the engine is a JavaScript engine, so it's an ECMAScript 2023 version. But the JavaScript community has a very, very rich set of tooling and multiple different toolings available to then transpile any of your fancy kind of like TypeScript down to the JavaScript version that we need to run in that. So we'll also be looking to have a lot of examples how to do that and transpile that. All of our examples are currently in a repository. They'll post later, are in TypeScript. But if you want to stick with ECMAScript modules, because ECMAScript 2023 is actually quite powerful these days, so you have a nice all like templating strings and all of that you get for free without even having to go to the fancier TypeScript. So all of that is kind of at your fingertips. It means you can also pull in extra libraries, because part of the transpilation step is to actually bundle everything into a single JavaScript module. It's like ECMAScript module technically. So because you're able to do that, so we have like an example that pulled in JSON Nada, which is a pretty big library, about 200 kilobytes, into a flow, and that works fine. So that's probably going a little bit, the pushing the limits there, but it just shows you how kind of flexible it is. We have one for protobuf translations because there's a nice JavaScript library to do the protobuf deserialization and serialization, and couple all of those nice features and binary payloads and all that kind of stuff with the Cumulocity upcoming MQT service feature. Then that leaves a very, very flexible kind of edge story that you can kind of meet a lot of very difficult requirements very easily, without getting to the complications of thinking too much in Linux. If you don't have too much experience in that and doing, init systems and you don't know what they are, then you don't need to worry about them. So that's really the whole advantage. And so we're looking to also assist from the developer side through examples, template projects, and all that kind of stuff. But it will be a progressive kind of buy-in. So everything might not be there at the beginning, but we're looking to then slowly go through examples, or you can, fork our GitHub repository and then use all the GitHub flows, so the workflows that we have to actually build everything and transpile everything. So all of that is public. So hopefully it should be quite easy to start seeing a bit of the vision, and then start to think about what use cases you can actually implement with these. Yeah, so feel free to ask any questions if you have any. There was already some questions in the chat, just in case if you weren't reading it, about will it integrate with software management plugins? Yes, we will have interface there to make it easy to install and remove from the cloud. There's a question about transparency of, will the Tedge Flows be published somewhere? So maybe the services tab in Cumulocity. Yes, that's our current thinking. It might not be there at the day one, but what will be there at day one is publishing statistics about the flows, like what flows are there, some rudimentary processing time, so how many errors and all that kind of stuff. So you could actually use all of that to create your own flow to create services, because the API for ThinEdge is quite easy to create, a service off a child device or the main device. So it should be actually quite trivial to even do that yourself, which I think just speaks to the power, the simplicity with it, and they can kind of extend it quite nicely. Okay, just reading a question from Jan. So the question is regarding kind of like, is there a way that multiple flows could basically share modules to save basically importing multiple times? So yes and no. If you go for the transpiled JavaScript approach, then no, because on one side, it's standalone. So you know that once you build this, that will work. So the moment you had kind of, you're importing dynamically things, then the system becomes a little bit harder to kind of reason with. However, if you did want to save kind of resources, technically you could use like share code by using the same steps, because we don't define that in a flow definition, which can have multiple steps, you could reference the same file. Yes. But I think we're talking about JavaScript, and generally they're not huge files. So in comparison to, you know, any kind of compiled thing, maybe bar-C, you're looking at, you know, megabytes. In JavaScript, we're really talking about like low kilobytes, if that. It kind of depends on, you know, what you're doing within it, you know, how big it is. But I think our biggest one was JSON, which is actually a huge library, and that was about 260 kilobytes uncompressed. And I don't think we were doing any minification and nothing like that. So I'd say if you're using like minification in JavaScript, which again, there's a million tools for that, that might even be more or like less in size. But yeah, I think the true nature of having a standalone entity that you know will work, and you have nice unit tests in your, you know, development code base, they can be sure that it will work, and, you know, it's not missing a dependency and all this kind of thing. So a little bit like the containerization approach, that you have everything you need to run your container in that element. Cool. Just a general question, like, does anyone have like immediate, you see this and going, hey, cool, I have a use case, I want to check it out, or are interested in looking at it and going, how do I actually use this? How do I fork your repository and all these things? Or are you still digesting the concept? I'll interpret silence as digesting the concept. But that's fine. Like, we were kind of, you know, as when things starting to get exposed, I mean, it takes a while to get a hang around it, like your head around it. So I think we'll definitely have a lot more like dedicated sessions and really start being shown some really awesome real world examples. Like, I mean, all the stuff that Didier showed were really examples, but like showing it end to end, like deploy from the cloud, how do I monitor it, and all those kinds of things. But yeah, we have a real focus on getting the interface sorted out and stabilized, or in the sense from a design point of view, so that when, you know, we're not going to be changing this to break all of your flows. So we'll take that very seriously. Yeah. So we're looking about like informal kind of deadlines, definitely Q1 next year for phase 1, which is like ability to install, remove flows with maybe local monitoring, and then phase 2 to follow afterwards of publishing the state of the flows to the cloud with maybe out-of-the-box functionality rather than having to write your own flow. Yeah. Cool. Okay. Then I guess that concludes our demo for today. So thanks for joining. We'll look to upload the video soon. And thanks a lot, and have a nice day.
Yeah.